So another thing I want to review with you for the ACT is square roots. If you were given, or how do you solve square root problems, one thing to keep in mind is that inverse operations exist. In order to get rid of multiplication, you divide. To get rid of division, you multiply. Addition and subtraction are inverse operations of each other. A square root and a square are actually inverse operations of each other as well. They cancel each other out. So if we were to look at an example, I was trying to get that to focus, but it didn't focus very well. So if I were to look at an example and I told you to take the square root of 2x minus 5, and if I said that was equal to 3, and I wanted to know what is the value of x. Well, in order to solve that, whatever you do to one side of the equation, you have to do to the other side of the equation. So the first thing, if the radical was not isolated, you would want to do that first. So for an example, if I told you we had the square root of 2x minus 5 minus 3 equals 0, the first thing to do is to isolate that radical and move this constant over to the other side. So then you would have the equation that we are starting with right now. Okay, that's better. Now I have it focused. All right, so we want to isolate that radical, and after you have the radical isolated, to get rid of the root, you raise it to the reciprocal power. So the root is actually the 1/2 power, and the reciprocal of that is 2. So the square root and the square are going to cancel each other out. What you do to one side, you have to do to the other side. So then you get 2x minus 5 is equal to 9, and I want to solve to find x. So I'm going to move the 5 over to the other side by addition, so you get 2x is equal to 14, and you divide by 2 and you find out that x is equal to 7. So you check yourself. So I'm going to put it into the original problem. 2 times x, which is 7, minus 5 is equal to 3. Well, you get the square root of 14 minus 5, which is the square root of 9, which is 3. So it does work. ACT purposes, you're not going to spend the time probably to check yourself, but you can find out. I just wanted to do that to prove to you that that is the solution. If you do have time, go back and check yourself. Okay, what if I asked you the square root of x minus 4 is a real number if and only if what? Well, as I look at this problem, I don't have an equal sign. It's not an equation. This is actually an expression. And they want to know, when is it a real number? Well, real numbers, we have the various classification of real numbers that we talked about clear back in 7th, 8th, 9th grade. The classification of real numbers, you start out and you are going to begin with your counting numbers, also known as natural numbers, 1, 2, 3, 4. You add a 0 and you now get whole numbers. If you take the positive and negative whole numbers, you are going to get integers, -3, -2, -1, 0, 1, 2. If I add fractions, it now becomes a rational number. If you cannot write it as a fraction, it becomes an irrational number, such as pi or e or the square root of 5. Those are all irrational numbers. And the large classification of all of those categories that I've just listed are real numbers. If it is not a real number, it is known as an imaginary number. And an imaginary number is when you take the square root of a negative number. It cannot happen. So if I said the square root of -5, that is the square root of 5i, which is not a real number, it's an imaginary number. If I told you what is the square root of -4, the negative turns into an I, so I get the square root of 4i, and the square root of 4 is 2. So that gives you an answer of 2i. Not a real number, it's an imaginary number. So if you were to talk about what is not a real number, it would give you an error on your calculator. Now, an error on your calculator, if you were to take the square root of -5 on your calculator, you're going to get an error. What has to happen is that the radicand has to be greater than or equal to 0, because if you take the square root of 0 on your calculator, you are going to get 0. So in this case, it asks you, it's a real number if and only if what happens, you find that radicand value and realize that that's got to be greater than or equal to 0. If I let it be -1, -1/2, -100, -0.001, which is -1,000, you're going to get an error on your calculator. Now, if they had another value underneath that radical sign, such as if I told you x plus 7 underneath the radical sign, and I say that that is a real number if and only if what, I would say that x plus 7, my radicand, has to be greater than or equal to 0. So if I solve, when you work with inequalities, you just move constants over to the other side, solve it as if it were an equal sign. If you divide or multiply by a negative number, you have to switch the inequality symbol. So I'm going to move the 7 over to the other side by subtracting it, and you get x is equal to or greater than or equal to -7. If I put -7 in here, I get 0. If I were to put -8 in there, I'm taking the square root of a negative number and it does not work. So I would have to say that x has to be greater than or equal to -7. Another way that you might encounter radicals on the ACT, they might ask you what integer most nearly approximates the square root of 40 times the square root of 30. Now, some of you are going to take the time to punch that in on your calculator. They're going to make it multiple choice, so you have an idea of what answers would be. But I could look at this and say the square root of 40. That is between the square root of 36, which is 6, and the square root of 49, which is 7. The square root of 30, that is between the square root of 25, which is 5, and the square root of 36, which is 6. So 6 times 5 is 30. 7 times 6 is 42. Your answer has to be somewhere between 30 and 42, because I've looked at the low ends and I looked at the high end, and it's got to be somewhere in between those two. Now, if you were to actually calculate it, I think you get, I don't know, 34 point something. But multiple choice wise, I would find what is the value between 30 and 42. I don't know if it's easier for you to type it in or just to quickly look at the numbers, but they will tell you the majority of the questions, or you could take the ACT test with absolutely no calculator. You do not need a calculator for it, and this would be where you do not need a calculator for it. And another thing that they might ask you to do when you are talking about radicals is they may give you something like example number 4. You have 4x over the square root of 4x minus z. And they're going to ask you what is another form of that. Okay, sorry about that. I paused it when I got the phone call. Now I don't remember what I was talking about. But another thing they could do for radicals is ask you for an equivalent form of the fraction that is given. An equivalent form would just be rationalizing that denominator, which is a lesson that we've already talked about. So if I want to rationalize that denominator, I'm going to take the radicand value times itself, 4x minus z, the square root of 4x minus z. So if you multiply the numerators together, you would get 4x, the square root of 4x minus z. And the denominator, remember, rationalizing, you take it times itself, because a radicand value, or if I were to take a radical times itself, they're going to perform inverse operations and get rid of that radical, so you end up with 4x minus z. Now, what you want to make sure you do not do is you cannot cancel the 4x's, because this x is not a factor in the denominator, so this is an equivalent form. And be careful, like I said, if it were a multiple choice question and they give you an answer that is the square root of 4x minus z over z, or a negative z, that is not your answer. Do not cancel those 4x's. Okay, so that is just a quick review over some square roots. I hope that helps. If you have any other questions, please let me know or attend the Zoom meeting.